for solving problem 17 from the AMC 10B from 2020. There are 10 people standing equally spaced around a circle. Each person knows exactly 3 of the other 9 people, the 2 people standing next to her or him, as well as the person directly across the circle. How many ways are there for the 10 people to split up into 5 pairs so that the members of each pair know each other? So 10 people, let's represent them as circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the 10 people standing. Well, let's just count the simple cases first. It's like we can just count the cases where they know each other from the people next to them. This is like this. So from this, if they know the person to the left and the right, and they choose like the person to the right to be their partner, that's 1. And then if they choose the person to their left, that's also 1. So there's 2 cases for this scenario. What if we introduce a diagonal? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we introduce one diagonal, we see that it has to be like this, because if these 2 were to group together, these 2 wouldn't know each other. So there's actually 5 ways of doing this, because there's 5 ways to connect this line between 2 people. Let's see, what if we had 2 lines? So by lines, I basically mean we're basically like putting them together because we're putting them across the table. If we make them to like have 2 lines across, let's do it like this. Group it like so. This is gonna be impossible. This is already impossible. There's an odd number of people. There's going to be a trio here, trio on each side. So 0 or impossible. Now let's go on to the next one. If there's going to be 3 of these diagonal lines. 1, 2, 3. Now let's see here. These 2 have to work together. Now since there's 3 lines, we can actually we can make this go 5 ways, because this can connect to 5 people and vice versa. So it is going to be like that. And we're almost done here. So we just need to consider 2 more cases. So if we add like 4 of these lines, connect it like this, 1, 2, 3, 4. This is essentially going to be impossible, because there's no way that these 2 people on the diagonal can. So we're considering there's 4 diagonals. Since there's 4 diagonals, we can't add a 5th one. So in this case, we let these 2 people like not know each other or something, because there's no way. The only way, if there were 4 diagonal, there's no way for this, because these 2 people are not next to each other. Instead, they're connected by a diagonal, and that's going to be 5 diagonals. So let's just move on to the last case where there's 5 diagonals. This is like 1, 2, 3, 4, 5 diagonals. Here we clearly see there's only 1 case, so we can sum up all these numbers. 2 plus 5 plus 5 plus 1 will give us our total number of cases, which is going to be 13 cases.